Welcome. Today we're going to talk about graphing some of the other trig functions. We've got tangent, cotangent, cosecant, and secant. We're going to talk about graphing and transforming those. So let's jump into tangent to begin with. Tangent is, so we've done sine and cosine, where sine was, as theta got bigger, we graphed the y coordinates, and cosine, as theta got bigger, we graphed the x coordinates. Tangent is the ratio of y divided by x. So as theta gets bigger, we're going to graph the ratio of y divided by x, 0 divided by 1, 1/2 divided by root 3 over 2, etc. And what that creates for us is some interesting graphs. We wind up with these like cubic functions, but they're periodic, so they show up again and again. And you have these vertical asymptotes at all the pi over 2's. The reason that's happening, let me show you how this works. I mean, theta is 0. When theta is 0, 0 divided by 1 is 0. So that's that coordinate right there. When theta is pi over 4, root 2 over 2 divided by root 2 over 2 is 1. So pi over 4, 1 would be right there. But notice what happened to pi over 2. 1 divided by 0. You can't divide by 0. Show me the vertical asymptote right here. If we wind up with a graph, okay, let's look at our notes here. It's a graph that has a period of pi. So it only goes from negative pi over 2 to pi over 2. That's the width of pi. It has a domain of all real numbers except for all of the multiples of pi over 2. Because every time we get to a pi over 2 in our unit circle, we're going to have it undefined. So that's these guys right here. The range is all real numbers. It goes up and down forever. So here's our formal definition of our domain. All real numbers except for the pi over 2. The odd multiples of pi over 2. And then the period is pi over b. This is different. It was 2 pi over b for sine and cosine. It's pi over b now. Range is all real numbers. It's an odd function. If you reflect and reflect twice, you wind up back where you started on the same graph. So it's symmetrical across the origin. So let's look at graphing and see how it goes. We're going to graph 3 tangent 2x. So let's deal with our original graph first. The parent function is being driven off the unit circle. Parent graph winds up working out from here to here. This is the graph we typically graph as the parent function. You could graph from here to here and have a valid picture. The one we typically use is from negative pi over 2 to pi over 2. So we're going to start at negative pi over 2. So our theta is negative pi over 2, right here. That is negative 1 divided by 0, which is undefined. So that's an asymptote. I'm going to do ASY for asymptote. That's this asymptote right there. We come over to pi over 4. That's negative root 2 over negative root 2 divided by 2 over root 2 divided by 2. That's going to be a negative 1. That's that point right there. Negative pi over 4, negative 4. Okay? At 0, we're going to have 0 divided by 1, which is 0. At pi over 4, we're going to have root 2 over 2 divided by root 2 over 2, which is positive 1. And at pi over 2, we're going to have asymptote again, because we're dividing by 0 again. So those are our 5 critical points that we're going to then transform using this guy right here. So 3 tangent 2x, a is 3, that's a vertical stretch of 3. B is 2, that means that we are actually going to be compressing this graph. Everything in the parentheses is always the opposite, so we're going to want dividing by 2. There is no h, there is no k, and our period is pi over b, which is pi over 2. Our period is pi over 2, so it's going to be a narrower graph. Let's take each x coordinate, divide by b, and subtract h. So negative pi over 2 divided by b. So b is 2. is going to be negative pi over 4. That's our first coordinate. All right, pi over 4 divided by 2, pi over 8, negative pi over 8. That should be negative pi. Negative pi over 8. 0 divided by 2 is just 0. And then pi over 4 divided by 2 is pi over 8. And pi over 2 divided by 2 is pi over 4. So those are going to be our coordinates right there. Our new y coordinates, the asymptote is still an asymptote. -1. So the a is 3. 3 times -1 plus a k of 0. It's going to be -3. 3 times 0 is going to be plus 0. It's going to be 0. 3 times a positive 1 plus a 0 is going to be 3. And that's still going to be an asymptote right there. Okay. So we're going to graph those guys. I got pi over 2's. Let's put tick marks there and there for pi over 4's. I need some pi over 8's as well. I'm going to put those tick marks right here. Pi over 8's. So negative pi over 4 is a vertical asymptote. Positive pi over 4 is a vertical asymptote. Then we got to graph our points here now. We've got negative pi over 8, -3. Way down here. 0, 0 is right there. And pi over 8, +3. It's right there. So this is almost just got just a little bit of curve to it. So that's tangent. Cotangent, very similar. Still driven off the unit circle. Remember, cotangent is x divided by y. So we're going to take our coordinates as theta gets bigger, and we're going to have the asymptotes in different spaces. The asymptotes wind up at 0 and pi, 2 pi, and 3 pi, etc. So this actually should just be in pi right here. Scratch that up. That should just be in pi. Period is still the same. Period is still pi over b. Range is still all real numbers. It's going to also be an odd function because if I reflect over and reflect down, I wind up on the same part of the graph. So both of these are odd functions. But like I said, our numbers come from different spaces. So we're going to start at 0 and go around to pi right here. So at 0, we have, and this is x divided by y now. So this is 1 divided by 0 is undefined. So 0 is an asymptote. Pi over 4, root 2 over 2 divided by root 2 over 2 is going to be 1. Sitting right here. It's pi over 4. Pi over 2. 0 divided by 1 is 0. 3 pi over 4. That's going to be negative root 2 over 2 over root 2 over 2, negative 1. That's sitting right here at negative 1. And then finally, pi, that's going to be an asymptote again, because again, that's undefined. 1 divided by 0 is undefined. All right. Our a is a half. Our b is pi over 2. Our h is 0. Our k is 0. Our period is pi divided by 1 by pi over 2. That's just going to be 2. So our new, so it's going to be wider. Okay, so remember everything in it and the parentheses is always the opposite because we're pi divided by 2, the pi's are going to cancel out and multiply. It's going to be a wider graph. So our new coordinates are going to be x divided by b minus h. So my x here divided by my b of pi over 2 minus an h. H is 0, so that's just going to be 0 right there. All right, this is going to be pi over 4 divided by pi over 2. That's being half. Pi over 2 divided by pi over 2. That's going to be a 1. 3 pi over 4 divided by 1 half, by pi over 2 rather. That's going to be 3 halves. And finally, we're going to have pi divided by pi over 2. That's going to be a 2. We're going from 0 to 2 here. Our new y coordinates, this is still an asymptote. That's the y coordinate divided times 1 half. So that's 1 half times that 1 plus 0 is 1 half. 1 half times 0 plus 0 is 0. 1 half times -1 plus 0 is 0. And then that's still an asymptote. Okay, so at 0, we got an asymptote. 2, we have an asymptote. Between there, at 1 half, 1 half, at 1, 0, and at 3 halves. Should have been a -1 half there. Let's cope. We're going to move the cosecant and secant. Something to catch up. Okay. All right. So cosecant and secant. So cosecant is the reciprocal of sine, and secant is reciprocal of cosine. What that means is we're going to wind up building our graph on top of the sine and cosine graphs. So if you look here, you can see the dotted line. That would be the sine graph. And so cosecant's being built on top of that. That's what these U's are right here. So the U's are the actual graph. The dotted lines are going to use to build it. So we look at our notes. We've got the same thing going on right here. This is the sine graph in blue. It's not actually part of the cosecant graph. You just use it to build the cosecant graph. The cosecant graph is the red U's. The things we know. The period's 2 pi. Domain is all real numbers except for integrals of pi, integral numbers of pi over 2 right here. So let's see here. Cosecant. Oh, that's secant here. Let's go back here. We got pi over domains, all numbers except multiples of pi. So we have n pi right here. So all real numbers, x not equal to n pi. Period still 2 pi over b. Range is different. So it's negative infinity to negative a. It's down here, and a to infinity. So up here. This is also an odd function because if you reflect and reflect again, you see it overlays the graph down here. Plus, it's built on the back of sine. We know that sine's an odd function, so it's going to be the same as that. So to graph cosecant of x plus pi over 4, we're going to draw the cosine graph. And then we're going to draw the asymptotes, then put the u's between the asymptotes. So let's deal with the cosine graph first. Let's go and label our parts. Here you've got A. A is 1. B is going to be, so if I no, I'm not, so B is just one. B is just one. My H is going to be pi over 4. My K is going to be 0. Here is going to be 2 pi over B, so it's just 2 pi right there. So I need to graph the cosine graph. Well, if we the sine graph rather. Now we know at this point, hopefully, that this is just the sine graph moved to the right pi over 4 units. I'm going to go to refresh your memory here. So sine is given by 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi. So our new graph, our transformed graph, these are all just moving right pi over 4 units. Moving left pi over 4 units. It's always the opposite side. Moving left pi over 4 units. So that becomes a 0 becomes a negative pi over 4. Pi over 2 is 2 pi over 4 becomes 1 pi over 4. Pi is 4 pi over 4 becomes 3 pi over 4. 6 pi over 4 minus pi over 4 is 5 pi over 4. And 2 pi is 8 pi over 4 minus 1 is 7 pi over 4. So there's a new x coordinates. The y coordinates aren't changing. So they're still 0, 1, 0, negative 1, 0. So let's graph that. Negative pi over 4, 0. Positive pi over 4, 1. 3 pi over 4, 0. 5 pi over 4. 5 pi over 4, negative 1's right there. And 7 pi over 4, 0. So that is the sine graph right there. Make sure those are right. Left. Those look right. Okay. All right. I didn't use some dashed lines because this is not part of the real graph. The real graph is built on its back. So I'm going to draw vertical asymptotes everywhere the sine graph crosses its midline, in this case, the x-axis. We're going to build U's back of this guy. Like that. We're using my back on. Still think I've got a mistake right here somewhere. This is not symmetric. It should be symmetric. Negative pi over 4, 2 should become pi over 4. Should be 5. I've made a mistake here somewhere, but I think you guys get the idea. All right, and finally, the secant graph. Hopefully, I'm having this correctly. Works exactly the same way. It's built on the back of cosine. Built on the back of cosine. So its asymptotes are at all the pi over 2's. So pi over 2 plus n pi. Its period is 2 pi over b. Same thing. Its range is negative infinity to negative a and positive a to positive infinity. It's an even function because it's built on the back of cosine. Cosine is an even function. All right, so we're going to draw the cosine graph. Definitely error right there. We're going to graph the sine graph for the last. All right. So let's say what our parts we have. A is 2, B is 2, H is 0, and K is 0. Our period is 2 pi divided by B, which is pi. It's built on the back of cosine. So let's lay out cosine's function right here. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. 2 pi 1, 2 pi 0 right there. Our new function. So we have a vertical stretch and a horizontal compression. So we're going to divide these by 2. So that is 0 divided by 2, still 0. That is pi over 2 divided by 2, which is pi over 4. It's pi divided by 2, which is just pi over 2. This is 3 pi over 2, becomes 3 pi over 4, and that's 2 pi divided by 2, which becomes pi. And then A is 2 times the y coordinate. So 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 is negative 2. 2 times 0 is 0. And 2 times 1 is 2. Okay, so I'm going to do the cosine graph. So 0, 2, pi over 4, 0, pi over 2, negative 2, 3 pi over 4, 0, and pi 2. So there is my cosine graph. And on top of that, we're going to build the secant graph. So I have asymptotes here. We're going to hug those asymptotes just like that. And on the left and right side, what we typically do is just draw half a U here because we've only got the tip these. This is one period. You can extend this thing out as far as you need to. So you match all of them. This is one period right here. Finally, a summary of all. This is just a summary of all 6 trig functions you'll be graphing. So sine starts at 0, 0, goes from negative 1 to 1, all real numbers, period 2 pi. Cosine starts at 0, 1. Same graph, just shift to the left. Tangent and cotangent, you've got your asymptotes. We won't label those. That's it. Pi over 4, pi over 2 right there. So negative pi over 2, positive pi over 2 right there. And these guys are at pi's. Cosecant is built on the back of the sine graph, and secant is built on the back of the cosine graph. There you go. I'll pick it up on the exercises here in a second.